Hi, my name is Christine Byrne, and I've chosen to do prompt 2 for exam video 3, where we'll be looking at the synapsis or the fusing together of chromosomes during meiosis in different individuals. So here are given the 2 chromosomes of individual 1, and the first thing we notice is that their gene patterns don't match up, meaning some sort of aberration has occurred. At first glance, it appears that the M, L, and the HG loci are mixed up. However, if we flip this chromosome without changing the actual order of the loci, we see that the actual aberrated area is the I centromere JK, and this is known as a pericentric inversion because this area of the chromosome has been flipped 180 degrees and it includes the centromere.
Understanding the inversion, we can draw these chromosomes out in a way by which they will pair correctly if no crossing over were to occur. We do that by making an inversion loop for the chromosome with the aberration. However, if there is crossing over during prophase 1, the result will produce chromatids that may or may not be viable. Let's take, for example, a crossover between the J and K regions here. One way to think about predicting these chromatids is to think about a train running along its track. If at any point there is a diversion in the tracks, the train will then be set to follow that new path and arrive at that new location. Crossing over between chromosomes is very similar. The gene patterns that are produced in each chromatid are a result of if and where the coding path diverged. So as you can see me write out these chromatids, my method is simply tracing the tracks of the chromosomes and following the crossover point as a bridge between the 2 chromosomes. And once we know the chromatids, we can assess whether they'd produce viable gametes. There are a few things that determine viability. Does the chromatid contain all of the genes as its parent chromosomes, or is it missing information? Are there duplicated or added portions of the chromosome? And are there extra or missing centromeres? For our example, we see that chromatid 2 and 4 are not viable because they both contain duplicated and missing regions.
Moving on to the second individual, here are the 2 chromosomes we're given. Once again, at first glance, they deceptively don't match up. But if we flip one of the chromosomes without actually rearranging the order of the loci, we see that they're actually the same. In other words, these are in fact homologous chromosomes.
Because there are no aberrations present, we can draw these chromosomes straight without any loops and they will still pair correctly. Similar to the first individual, we can predict the chromatids produced after a given crossover in the JK region. Using the previous analogy of a train following along its tracks, we can perform the same method for this situation, using the crossover as a bridge between the chromosomes. Even with a crossover event, we see that all 4 chromatids will produce viable gametes because they all contain the necessary genetic information as their parent chromosomes did. In regards to fitness of the individuals, I would predict individual 2 to have a greater fitness due to the greater viability of their chromatids, meaning both their reproduction and survival rates would be higher.